Hi, everyone. This is Jung Rajiv from PhD Expertise. Today, we're excited to be with our guest, Dr. Hobey Tam. Hobey graduated from Rose-Hulman in 2012 with a bachelor degree in Biomedical Engineering, and from Clemson University in 2016 with a PhD in Bioengineering. He worked as a research associate and adjunct faculty at Clemson. Meanwhile, he also founded BlackTop Labs in 2015 and has been the CTO of another company, PursuitAlert, since 2016. Now he works and lives in the bicycle capital of the world, Amsterdam. Welcome to the program, Hobey.
Welcome.
Thanks for having me, guys.
Yeah. So I will kick off with a question on your PhD. So your advisor was well regarded for the cardiovascular implants. Can you briefly talk about some of the research project you worked there?
The Via Vihari lab predominantly works in the cardiovascular space, like you mentioned, and it's a biomaterials lab. So what we do is we make better implant materials for cardiovascular applications. Those applications range from replacement heart valves, cardiac patches, replacement arteries. And so any type of, whenever you have like a heart attack and you need a cabbage. And so when you have like a stroke, you have to take out that, you have to take out the artery, and then you have to replace that artery with something. Or if you have an aortic heart valve replacement, you have to take out the old valve that's broken and you have to put the new valve in. And so that's what we worked on, is making materials that would last longer in the body and work better for those specific applications.
All right. Can you talk a little more the specific thing you worked on?
So I was on the heart valve materials project. And so that was a big polymer chemistry project. And what we did was we tried to figure out what is the next material. And so there's tissue engineered materials, or you can still have a polymer or a cross-linked animal tissue that has been rendered non-immunogenic, so it doesn't get rejected from the body. And so those are kind of the three options. And we said, hey, current manufacturing processes already use animal tissue. And so why don't we just find a better way to cross-link these tissues, and you can literally you can use the same manufacturing process, but it's a different chemical soup that they're treating the material in. And you can use all the same downstream processes as well. And so that's what my project was trying to find this new chemical mix. And we ended up actually finding a better chemical mix, and we patented it. And currently they're trying to license it out to a heart valve producer.
Gotcha. So at Clemson, sorry, you want to?
Yeah, no, that's real. It's really interesting what you're saying. So what type of, it sounds like you were doing a lot more of the sort of the modeling work. Is that the way to think about your project? Were you an experimentalist?
I was actually more in the chemistry, trying to figure out, okay, what's the best chemistry to use, how to optimize that chemistry, and then actually make the material and then test it in animals for biocompatibility. And so we use animal models to try and create some of the failure modes that are in current heart valves. So for instance, right now, heart valves often calcify, and so do the replacement valves. And when you imagine a heart valve in your heart, and obviously you want something that's kind of flexible and kind of goes like this, low turbulence, and the blood can just shoot through the valve. But when you have calcification, the valve leaflets, they kind of turn into cornflakes. And so obviously you're not going to get good flow. The area, effective area, the blood can flow through is going to reduce, and that's going to cause a lot of downstream systemic issues from the cardiovascular perspective. And so what we said was, hey, can we make a material that doesn't calcify and doesn't rip like the current material? And so we cross-linked it with different agents, so that chemical soup. And then I would take that valve and then put it inside of like an accelerated calcification model in rats. We've done it in rabbits. We've even made cardiac patches with the same cross-linking material, and did like a big sheep experiment. So I was actually more on the chemical side, and then also on a lot of like making bioreactors, like in vitro testing, so fatigue testing, as well as doing a lot of animal work. And so I was exposed to a lot of different types of disciplines throughout my PhD. It wasn't, I would say it was more of like putting a puzzle together rather than actually just finding like one or two puzzle pieces like most PhDs.
Gotcha. At Clemson, you were able to complete your PhD with less than 4 years, and you also found time to volunteer and develop curriculum and teach at Arusha Technical College in Tanzania. Can you tell us about your experience there?
Yeah. Well, first, I think the question is, how did I have enough time to do that?
Yes, yeah. For sure.
So if you break down a week, let's say you have 24 hours and then you have 7 days. And so let's subtract out 8 hours of sleep and let's say 2 to 4 hours of eating, shitting, and exercising, whatever, each day. You still have over 90 hours every week to work. And so when you actually look at a grad student, or when you like, I want it to all the grad students currently listening to this and thinking that I can't graduate in that amount of time or whatever, really figure out, okay, am I utilizing that 90 hours correctly? And then if you're working long hours, okay, that tells me you're committed. But the second question is, do I have the project management skills to use my time wisely? So you're working smart and hard, right? And in grad students, I see one or the other. It's very rare that I see both or none at all. Okay. So the second thing is to get project management skills. If you're not meeting with your advisor or some type of mentor and not getting feedback at least every other week, I would say that you're already pushing out your timeline. Like every month that goes by that you don't meet your professor, I would add 5% to your PhD. Every time you're afraid to meet with your advisor, add 10%, because that means that you're not being productive and you're too afraid to ask questions and your pride won't let you seek help. And third of all, when you're going into these meetings, are you tracking exactly what you guys want to do? Are all the actions you're doing actually going to result in moving the needle forward in what you're doing? I see a lot of people wasting time on research that really it's not going to help their thesis. It's not going to help their metrics of their advisor. It's not going to help the university. It's really just kind of like going down a rabbit hole and not really understanding why you're going down that rabbit hole. And so my advisor calls it blind research. That I see a lot of that happening. And basically the antidote to all this is when you set out to do a study, make sure you outline that entire study and you already know how to write the paper before you start the study. And yes, things will change. Maybe 30, 40, even 60% of that paper is going to change. But if you don't have an idea of cost, timelines, and what those results figures are going to look like and what the reviewer is really going to do, if you didn't email the editor of the journal that you plan on applying to and saying that, hey, do you guys even think that this is a valuable idea? Like, what are you doing? Right. And so you don't want to, the saying in product development goes, you don't want to design the perfect hammer, spend all this time, money, and effort doing that, and then go out in the world and find out it's filled with screws. So you always want to plan and test first, and then fail quick, and then, get to something that works, move the needle, and then reevaluate. And, really just, it's week by week. No matter what, every week produce a figure. 90% of the weeks, those figures are going to be trash, but you need those failures to get, because if you look at the roadmap to success, it's littered with failure, and you have to learn from each of those failures to advance. So if you're not making those failures, you're just staying at the same point. And that's what I see a lot of grad students do. And again, out of pride, they put themselves on an island and they're too afraid or they're too prideful to ask for help. And so when you talk about how did I do all this in less than 4 years, it's I'm not afraid to fail, and I'm not some smart dude. I'm just smart enough to try a different way every time, and I'm too stupid to quit. Okay, and I think that's carried over nicely to entrepreneurship. And when you ask about why did I teach in Africa, I got an email one day and it said, hey, it was like this long email. They needed someone to teach anatomy and physiology in Africa. And all I read was trip to Africa. And so I responded and thought that, oh my God, it's been 2 hours. Someone else has got my spot. I was the only person that responded. So, like 6 months later, in retrospect, I probably should have planned it a little bit more. I'm talking out both sides of my ass right now, talking about make sure you plan well. But when it comes to traveling, I'm like a pure backpacker. And so I just kind of like packed a bag the day of that I left for Tanzania. And then like I landed and I was like, I don't know who's going to pick me up. I don't speak Swahili. But I think the people that give the most receive the most. And so I've always had that mentality. And like I've gone back for the past 7 years. And so I've climbed Kilimanjaro. I've gone to Ngorongoro Crater, took all the safaris, gone to Zanzibar. I've been to Victoria Falls. Again, the people who give the most receive the most. And I highly encourage, like, it may be counterintuitive. A lot of grad students are sitting there. It's like, I have so much work already. Why would I pile on more work? Well, I will challenge that. Are you really working hard enough? I've taught over 200 students now. Most students are maybe working at 10, 20% capacity, right? Because I graduated from Rose and then I go to a semester school. You have to deal with me for 18 weeks. And students always say we have a really high workload. I'm like, this is just normal stuff. We do this in 10 weeks at Rose. And so you need to deal with this and figure out your real capacity to work. And so one, I would say that most students are using about 10 to 20% of the real capacity. And two, the more work you pile on, the more you're forced to be efficient. And if you're going to pile on more work, make sure that it's rewarding. And for me, teaching in Tanzania was very rewarding. And so just chase the dream, not the paper.
Man, that is, I mean, I got goosebumps talking. I totally agree with you. Having goals and getting constant feedback is the way to get through your PhD more efficiently and more impactfully. And this idea that I commend you, this idea that you went to Tanzania with a backpack, but it was just like, hey, I'm going to do this because this is something that's interesting to me. That's awesome. So I think, Jung, if you don't have anything else there, I have the next sort of question here, right?
Yeah, go ahead.
Yeah. I mean, I think a natural transition from that conversation is like you started BlackTop Labs, right? And that's in the Netherlands. You were effectively, you and your co-founder, work through this. And I think it's like targeted towards for almost like an aid to physiotherapists, right? Or physical therapists is like that, being able to do diagnosis and these type of things. That would be the end goal, right? And preventative medicine. Can you just talk a little bit about what the organization's about and what what your ultimate goal is here?
Yeah. So BlackTop Labs, the idea started, it's kind of after I graduated, and we were actually just watching basketball, and we saw, it was during March Madness, and we saw just injuries, like preventable injuries. And we wanted to see our favorite players play. That's really how it started off. And then, as any good engineers would do, we bought a case of Yingling, and then went online on McMasterCard and SparkFun, just bought all these sensors. And, you're an engineer, so kick back, drink some beers. And we just went on this binge. And then we had this first prototype, and we said, hey, this thing can measure the movement and detect deviations in technique of athletes. So we can actually figure out, hey, are there markers for injury? And so we can get into the injury prevention thing. Okay. And so at this point, we called our prototype the Medusa because it was literally spaghetti wire. And it was like the size of a football. And so now it's like the size of this. Okay. And so this measures medical grade EMG. So we take the signals from muscles, and it was actually developed for respiratory EMG monitoring for babies in the NICU. That's what's in the clinical trials for right now. But we said, hey, we can use that because it also has an inertial measurement unit on it as well, an IMU. And so that can actually help us segment the data better. And essentially, it's like this long 3-4 year journey since then. But the idea is exactly as you said, is to create an aid for physiotherapists or coaches, a diagnostic tool to make better decisions. Because right now, there's like these umbrella plans because these stakeholders just don't have enough information to do much else unless you're in like this amazing lab with a bunch of other diagnostic equipment. So what we said was, hey, muscles are responsible for work. They make us move. So why don't we go direct to the source, figure out deviations in muscle activation patterns, and hyper specify training programs or rehabilitation programs based on EMG data. And so that's really the basis behind the company. And obviously the business model has changed. I think our first business plan, our first pitch deck that we made to investors said that, hey, we're going to be on market in 2017. Okay, it's been 3 years. We're literally still in, like, we're rolling out in pilot sites now. So we're like barely revenue generating. So, but that's just normal for startups. My biggest tip to anybody who's planning to start a company, have a real job, save up money so you don't have to make money for at least 3 years, and at night moonlight the startup from not only a technical perspective, but the business perspective as well. And that it's literally free. You pick up your phone and you call people. That's it.
Yeah, no, that's really interesting. And can you talk a little bit? You mentioned about being in the Netherlands and all that, but can you talk a little bit about the difference in the culture, the entrepreneurial culture, U.S. and the Netherlands?
Yeah, I will say this: the reason why we moved to the Netherlands was actually for an accelerator program. They were here, especially with healthcare. They're much more open to collaboration. Like Tanya Colonna is also a Rose alum, and we both co-founded BlackTop. That's a crazy story that's for another podcast as well. But essentially, we don't know any rich people in the US. Like you can go to any entrepreneurship conference and whatever, and they always say, hey, if your value proposition is clear enough, investors will buy on. If this, and that, investors will invest. But at the end of the day, investors already know if they're going to invest probably 30 seconds from meeting you. And that's just the plain truth. And if they were truly if they truly invested based on merit criteria, then we would probably have investment in the US, but we really couldn't get the traction going on in the US. We couldn't get customer input in the US, which really hindered product development. And so we said, okay, we need a better ecosystem. And we just went on Google, and the algorithm took us to the Netherlands. And when you come here to the Netherlands, there's a lot more non-dilutive funding. So there's a lot more grant money for a startup to compete for. And obviously it's a very small country. So they have to have good business incentives, good tax incentives, as well as this non-dilutive funding culture to attract business there, because you can only grow so much with 15 million people. And so they attract people here, and they create like these hyper close-knit business cells. And it's like it's like Caesar's saying, would you rather be second in a city or first in a village? And so you always want to be the big fish in a smaller pond. And that's kind of how we viewed the move to the Netherlands. Maybe we'll transition back to the US because the business is double-edged. There's no perfect business place, right? In the US, you have ample amount of investors, and they're way more risk-taking, for example, than the EU. However, the EU has a lot more non-dilutive funding, and maybe you can actually train and get way more face time with stakeholders early on in your growth stages of your startup. And maybe you go back to the US, which is a bigger capital market, when you scale. And so it all depends on the business case. For us, because we were going for neuromuscular and there's a high prevalence of neuromuscular disorder here, healthy aging and a lot of grants were targeted specifically for that. So the move made sense for us. But for any PhD or technical person looking to create a company from a technological concept, what I would really research is what's the value I bring and where does that value have the most impact? Go there first. Don't assume that a larger market will equal larger impact. Really talk to customers and really figure out who is willing to work with me right now and go there first.
Yeah, for sure. No, thanks for that. And no, that's really interesting. And there's a lot of elements to that. We're going to have to, John, we have to make a note, certainly bringing Hobey back on and talking through some of these things. Hobey, in our last minute, could you, just give one piece of advice for the PhD who's graduating, or the person who is, working in a career that they might not be enjoying as much, about how to make their next decision, right? What would be one thing that you could tell them to help them make their next decision, what they want to do?
That's a very deep question. And what I would advise is figure out your why. Like, go on a run on a weekend and run as far as you can. And then when you think you're going to quit, keep on going, because most people don't run far enough to find their second win. Like, right now, like, I just ran my third 4-mile round today, and I have 2 more 4 miles. So I'm running 20 miles today.
Wow.
And, like, on that run, when you're about to quit, the only question in your head is, why am I doing this? And if you don't have a good why, you will quit. And most people quit before they start. Most people are capable of climbing Mount Everest, but they don't do it because they trick themselves into thinking that they can't do it, or they have no need to do it. So it's not that they can't do it, they won't do it. And this is what we do every single year with a new cohort of students. Like, it's not that they think they can't do the work, but when I dangle the grade in front of them and I'm saying, okay, you're going to fail and you're not going to graduate if you don't do this work, all of a sudden they can do it. So again, what is your why? If you don't know that, then everything will feel like suffering. But if you know your why, then you understand why you're doing the things that you do. You understand the meaning behind it. You understand the struggle. You learn to love the struggle. And on the other side of struggle are all the gains and benefits. But without passing through that trial by fire first, you're not really going to get anywhere. And that's just the blunt truth. And so if you don't know your why, figure it out. And you only figure that out by experiencing discomfort. So you need to lean into adversity. And so I don't care if you need to run as far as you can, sign up for an ultra marathon and, show up to the start line, or go on a coding spree for 48 hours. Like, do something that really tests you, and then figure out why you do the things that you do.
Wow.
And once you figure that out, a plan will start to appear.
That is super inspiring, and we're out of time, but we want to thank Hobey for chatting with us today. This has been a really, I would recommend everyone, you probably already watched this if you've gotten to this point, but rewatch this video. This is a good video. And we'll definitely have Hobey back, but we want to thank him again today, and keep watching on our channel. And if you have any questions for Hobey, send us an email at phdexpertiseteam@gmail.com, and we'll forward it on to him and get you connected. Everyone have a great week, and best of luck, and know your why.
Awesome.